So here's the next thing that we're going to review, which is graphing f from f prime. That's where you have graphs that look like this. And it says the graph of f prime is shown. Show a possible sketch of the graph of f. So what I always look for first is your maxes and mins. Where does f prime, says f prime is shown. That'd be nice if I labeled this f prime and that one. All right, so look for where f prime changes from negative to positive and positive to negative. So we see f prime changing negative to positive here. So that's going to be a min. I might also notice that before that point, f prime is always negative, means f is always decreasing before that point. So I might think of putting this min pretty low down, just for the matter of giving myself room to sketch. And then this is a max because f prime changes from positive to negative, so we're going to have a max there. So I want to sort of indicate that this is a min and this is a max. All right. Now, you have to figure out what to do with things like this. So when you see f prime just touch the axis and go back, that's a point where f has a horizontal tangent, but not a maximum or minimum. So it means it's going to have like a shoulder. Right? Notice that f prime is negative for this whole interval from here to here. That means f prime has to always be decreasing from here to here and has to have a horizontal tangent here. So how's that going to look? It's going to have to go down and have like a little shoulder and then go down some more. And then it's going to have its min, and then we just connect the min to the max. So I'm just connecting up. You know, once you note your mins, maxes, and horizontal tangents, just connect them and it's going to be good. All right? You can look at degrees, but be careful not to be misled. So here you have a 4th degree, clearly f prime is 4th degree, right? So f should be 5th degree. So we should see up to 4 turning points, but I only see 2 turning points. So that's because 2 of the turning points are sort of tied up in here. This would be a point where f prime has multiplicity 2. So you're not necessarily going to see all of the turning points that a 5th degree polynomial should have. So don't get too hung up on the degree analysis. You can look at concavity just to see if it sort of matches up. We have f prime increasing, f is concave up. We have f prime decreasing, f is concave down. Then we have f prime changing to increasing here. Well, it sort of looks like I'm a little concave up-ish here. So if you wanted, you could sort of bring this more like this and then make this tighter so that it looks more concave up. But that's really sort of a very minor point that you would not lose points for. The fact that this has to change to concave down exactly right there. And then what else do we have? So f prime is increasing, so we're concave up. This should be concave up. And f prime starts decreasing right here at x equals 6. So we're concave up, concave up, concave up here. X equals 6, we should change to concave down. So we can kind of see that we're concave up in here and concave down over here. So you can kind of see that. But again, don't get hung up on concavity. The concavity will come out in the wash. So let's just do one more example like that. Here's a little bit simpler one. So just like I said, first look for your maxes and mins. Here's f prime changes positive to negative. Therefore, f has a max at that x coordinate. Make sure that your x coordinate of your max matches the x coordinate of the x-intercept of f prime, right? And then here is a point where we have a horizontal tangent, but f prime is negative from -4 to infinity, so f has to be decreasing -4 to infinity. If you want to really think about the inflection point better this time, here's where the inflection point should be. So we should be concave up everywhere from here to here. So this should all be concave up here. And this should all be concave down here. But, that's just a matter of how exactly you draw this curve, and I'm not going to fault you for that. But, for example, if you start going up here, then you're dead wrong, because f prime is negative, so f has to be decreasing. Now, f prime is also decreasing, so f should be concave down, and that would be nice if we show that. Then over here, f prime is positive, so f is increasing. Right? F prime is decreasing, so f is concave down, and there's our f. It'd be nice if we label our graphs f. All right, so there you go. That's graphing f from f prime.